we're gonna start our 10th module, which is our DOS attack. So we can see DOS concept, and we're gonna start with our module 10th, which is denial of service attack, a DOS attack. So we're gonna try to manipulate, and over here I'm gonna need a attacker machine, and over here I'm gonna need a victim machine. So for the victim machine, I'm gonna use a Windows server. You can use any of the Windows XP 7 or 10. So over here we have an attacker. And victim. So over here we can see on the screen, which is called denial of service attack, is simple as DOS. So over here we have image, we have attacker, we have victim server, we have some zombies, and some botnets. So before starting the, let's explain this one. So in this scenario, a DOS attack is an attempt. So it is a type of attack in which the service offered by the system or a network is denied. Service may either be denied, reduce the functionality, or prevent the access of the resources, even the legitimate users. There are several techniques to perform DOS attacks, such as gathering a large number of requests to the target system, and these large number of incoming requests overload the system capacity to entertain, resulting denial of service. So over here, if think about a normal thing. For example, when you're doing a google.com or any of the website you are visiting, so simple from the client side, you will send a synchronization packet, a sync packet. Think about the three-way handshake, how we can communicate with the target. So there is a three-way handshake method that we always try to use to manipulate or simply connect to any of the systems on the worldwide. So over here, you can see the attacker is on his own network and the server is in a different network. So how the attacker accomplish a simple DOS attack? Basically, there will be some compromised species, which is known as zombies, and there will be some botnets, which is controlled by the common malware, which is infected by the common malwares. So in this proper sequence, you can see zombies, botnets attempting to a DOS attack. Instead of the attacker, attacker will simply send some his bots and zombies to perform a simple denial of service attack. So how does it work? So in the backend, if I'm simply sending a request to any of the server, so it will send a simple sync packet, a synchronization packet to the server. So if you see over here, the common symptoms of a DOS attacks are like slow performance, increase in spam emails, unavailability of resources, loss of access of the website, disconnection of a wireless or a wired internet connection, denial access of internet services. So there are lots of things that we can use it for manipulation, or we can simply for attacking. And there is one more thing which is we need to know, which is your distributed denial of service attack, which is your DDoS attack, which is the most cause or most disaster attack we can say. So over here, if you see over here, similar to the denial of service attack, in which an attacker is attempting to a DOS attack, in distributed denial of service, multiple compromised systems are involved to attack a target, causing a denial of service. A botnet are used for DDoS attacks. So over here, we can see that an attacker is performing a DDoS attacks with the help of some botnets and some compromised server, which is known as zombies. So in this scenario, the most of the people, most of the hacker, they perform DDoS attack in the big website. They need a bunch of armies over there. So over here, they're saying how distributed denial of service attack works. So this is the most common thing. So if you see over here, normally an established connection consists of some steps in which a user sends a request to a server to authenticate it. So in this scenario, it's all about three-way handshake. So if you look for the Google three-way handshake. So over here, they have given a proper video. So how the three-way handshake works when you are simply communicating with the server. It's the client will send a synchronization packet to the server will send a sync plus act packet that indicates that the packet was received from the client and acknowledged a recipient. and then the client will send an acknowledgement to make a proper three-way handshake. But in this scenario of DDoS attack, the server returns the authentication approval, requesting user acknowledge it with the approval that then the connection is established and allowed on the server side. So it's a proper three-way handshake over here. So if you see on the screen again in the bottom line, denial of service attack, the attacker sends several authentication requests to the server. Several authentication requests. It means lots of synchronization packet. These requests has fake return address, means there will be no return address where to response back. So the server can't find a user to send authentication approval. This authentication process wait for a certain times to connection close. The attacker is continuously sending a request, causing a number of open connection ports on the server side. So if you see over here, the DDoS attack and the DOS attack techniques there are lots of techniques that you can use. For example, volumetric attack. This attack is basically focused on the bandwidth of 100 GPS of bandwidth. Denial of service attack performed by sending a high amount of traffic towards the target. Volumetric attacks are focused on overloading the bandwidth consumption capability. Bandwidth, a frequency, we can say. This volumetric attacks are attempted with the intention to slow down the performance degradations of services. Typically, these attacks are consuming bandwidth in hundreds of GBps of bandwidth. So it's all about the fake traffic that we send on the server side. Same volumetric attack, there is a fragmentation attack also. A fragmentation attack which basically works on the UDP and TCP port. If you talk about the UDP port, it will basically use to consume the Icmp fragmentation attack. So if I talk about the Icmp, Internet Control Message Protocol, you will see DOS fragmentation attacks are the attack which fragment the IP datagram into multiple smaller size packets. This fragmentation packet requires assembling the destination with the required results of your routers. Fragmentation attacks can be followed by UDP or Icmp fragmentation attack or TCP fragmentation attack. If we talk about the Icmp protocol, so in the Icmp protocol, when we are performing a ping scan to a network like my local host, basically it will create a 64 bytes of packet. But in the meanwhile, if you simply open your Wireshark, so over here I'm going to ping my router IP address, and I'm going to use some filters with the 110, which is my IP address. So let's use ip.addr, that is 1068.1110, and function, and I'm going to use ip.addr is equal to my router IP address. So let's try a simple ping attack. So over here I can see from the source, which is 110, is sending a request on the router, which is Icmp packet, and the length of the packet is 98, and this is a echo request packet. So either you can simply check the packet over here on the bottom side, which is your source and destination, we can see, and the message over here, the most important thing is the message. So over here the message is a request method and a response from the server side. If you check the data, the length of the packet. So our main concern about this one was simply how a ping request or attack cause, because over here the Icmp protocol basically used for request to check, request and response to check whether the host is live or not. So if you see over here, TCP state execution attack, so are focused on web server, firewall, and load balancer and other infrastructure component to disrupt connection by the consuming the connection state or tables. TCP state exhaustion attack. TCP states exhaustion attack result in exhausting their finite number of current connection the target device can support. The most common state exhaustion attack is ping of death. And ping of death is a major attack in the 90s. If you see over here, see this one. So over here, if you simply, let's do this one. What is a ping of death? And through the ping of death, there is an ICMP flood attack also. An ICMP request requires the server to process the request and respond, consuming the CPU resources. When you are doing a ping command or executing any of the ICMP protocol, it will consume the CPU resources. The attack on the ICMP includes Smurf attack, ICMP flood attack, and ping flood attack, all which take advantages of the situation by flooding the server with the ICMP request without waiting for the response. So we are not going to accept any of the response from the server side. We're going to simply continuously sending the request. Same just like if you see over here, the ping of death. A true classic intent originating in the mid of late 90s. The ping of death was a ping packet that was larger than the allowable 64K packet. So when we are doing a ping request, so see over here, the packet which is generated from the ping is only 64 bytes of packet. .64 bytes of packet can be generated from when we are performing a ping. But in the ping of death, we exceed the limit of 64 byte. Although not much of significant threats today due to ping blocking. Yes. Now, because of the ping blocking, ping of death will not work. OS patching and general awareness. Ping of death was a formidable and extremely easy to use DOS exploit. And mostly it will basically attack on the Windows server. Let's perform a ping of death attack with the help of Windows. So over here, we can see a command ping -n, which is your length. And we're going to use 65,540 and the host IP address. Or we can try the ping and the IP address of the target plus the number of length of the packet, -w the workers with the number of connections, and -n the number of sets. How many requests we're gonna send. So before that, over here I'm gonna use my Windows server, run as administrator. Yeah, so we are on the administrator right now. And let me check my IP address first of all. So my IP is 108, and over here we're gonna use 108 IP address to communicate. So let's start. So has started. The packet has been started. So over here I'm going to use the filters from the IP address 192.168.1.0.10 and the IP address between 108. So I'm going to use over here the CMD, and we're going to use ping, the IP address, the number of length of packet. So I'm going to use -L 655500, the workers. So I'm going to use 100 workers and I'm going to send 100 connections. So let's try with this one. So over here I can see the first was timeout, then the request has been completing one by one. Replying from the packet, the original bytes have been changed and the TTL is 64. Let's see over here on the over here. And you will see one thing, that this is a fragmented IP protocol. Fragment means it's been modified. So over here we can see that we're not gonna accept any response code, and you can open any of the packet over here. Mm, source and the destination, you can see over here the proper way, and the bytes of the packets. So the word fragment over here, that means that the packet was crafted, it was modified. Due to ping blocking nowadays, ping of death will not work, but many of the many of the websites are being hosted on the Windows XP, and ping of death will work over there. But most of the cases, it will not work. Because when we are performing a ping of death attack, it will basically consume the memory. So over here, 97 packet has been sent, and the 3 packet was lost. You can see over here that was timeout. Yes, 3 packet was lost. The first packet was lost over there. So over here we can see when we are performing a ping of death attack, we basically use, I'm gonna use 0. But through the 0, I can see that I can simply put the range from 1 to around this much of that. So the most common thing, ping of death attack will not work nowadays because of the ping blocking attack. And most of the cases nowadays, attacker use different techniques to prevent. That's why the TCP state exhaustion attack was basically to consume the memory resources, consuming the connection state tables. That's why we have application layer attack. You can see over here an application layer attack, an application DDoS. This is the DDoS attack, is also known as layer 7 DDoS attack. Application level DOS attack is performed by the DDoS attack, which focus on the application layer of the OSM model, resulting in the denial of deprecations of services. The application level attack overload the particular services feature of the website and application with the intention of denial of unavailability. So it means it's all about the resources. If we are using any application, for example, if we are using any other application like way to SMS, this was a time that we used this one for free SMSs. So over here, the main objective, when we can see that application layer attack is basically to unavailability of the resources of the application that a legitimate user can't get access. So it means unavailability of the resources means totally proper DDoS attack with the help of armies or botnet or zombies. We're gonna perform this kind of attacks over here. For example, let's try to read this one also. DOS attack with the Ddos Techniques. So it's a bandwidth attack. A bandwidth attack requires multiple sources to generate a request to overload the target. The DDoS attack using a single machine is not capable for generating enough requests which can overlap the services of the distributed DOS attack. It is very effective techniques to flood requests towards a target using the distributed attack. So it means we need a bunch of armies to attack on the target server, because the target server, we doesn't know which processor they are using. That's why most of the attackers, to perform a DDoS attack, you can see an enough request. Enough request, which means a synchronization packet, which will consume the memory traffic over there. You can see the bandwidth completely consumed by the legitimate traffics. If you see a proper attack, you will see, as we know, zombies are the compromised system, which is controlled by the master controller, which is attacker or controlling zombies through handler, provides supports to initiate DDoS attacks. Botnets defined later in this used to perform DDoS attack by flooding Icmp eco-floods. See, the goal of this bandwidth attack is to consume the bandwidth completely. No bandwidth is left even for legitimate user. So we can see the legitimate traffic, the normal user over here. But attacker using some botnets and zombies to create some fake traffics on the server side. Zombies are botnets attempt in DDoS attacks. Bandwidth completely consumed by the DDoS attacks. No place for legitimate traffic because there is much more request either than the legitimate traffics. So over here, by comparing the web figures, you will understand how distributed internet service attack works by consuming the entire bandwidth. Legitimate traffic is denied. When we are performing a DDoS attack, the legitimate traffic will be revert back or it will not reach to the server because the target server is basically analyzing the request which is more larger than the legitimate one. So over here, the most important part, you will see some attack we're going to perform, which is called your sync attack flood. We're going to try this one. And before that, we can see service request flood, which is an attack also. Service request flood is a DOS attack in which attacker flood the request towards a service, which is a web application or a web server, until the service is overloaded. When a legitimate user attempts to initiate a connection, it will be denied because the repeated TCP connection by the attacker consumed all resources on the point exhaustions. So we're going to try this service request flood with the help of sync attack flooding. We're gonna send large number of packets to the target server that it will not simply connect to a legitimate device on the network. So let me show you. We're gonna perform a sync attack flood. So over here, I'm gonna use Metasploit over here. And in the Metasploit, we're gonna perform a sync attack flood. So you will see sync attack flood or sync flood exploit the three-way handshake. So the attacker will sending a lot of sync requests to the target server with the intention of tying up a system. This sync request has a fake source IP address which could not be found in the victim. Victim waits for the acknowledgement from the IP address and there will be no response from the source address. For incoming sync request was bad. This waiting period ties up to connection, listen to the query, and the system because will not receive an ACK. So over here, the attacker will send, it's a proper three-way handshake, you can see. Sync packet with actual source IP address, sync plus ACK and acknowledgement. So three-way handshake was completing with the resource. So, but over here in the sync thread, the attacker will send some synchronization packets, a lots of synchronization packet. The bogus source means fake address. Open the connection waiting for the ACK packet because we will not accept the sync plus ACK packet from the server side. So over here, if you see, we're gonna use Metasploit. For this, I'm gonna use search sync flood. Yes. Okay, so we're gonna perform a sync plus flood attack with the help of Metasploit. So over here, we're gonna use some auxiliaries. Okay, so I need to find this one in this totally mess. So I'm gonna use search. I'm gonna type. So over here, oh man. Let's run the Metasploit again. So over here, I'm going to use the search with the auxiliary. I'm going to write type over here. And I'm going to write sync flood. Okay. Yeah. So you have to write search with the type auxiliary and the name of that specific one. So over here we can see auxiliary DOS TCP flood. So we're gonna try the sync flood attack. So I'm gonna use this one. So use auxiliary. Show options. So in the show options, we have to select the R host, the R port, the port that we're gonna attack. So as host spoofable source address, it means we can simply randomize the IP address. And over here, we're gonna use a set R host. So over here, I'm gonna use the Windows server. So I'm gonna use the Windows server over here. So set R host with IP address 108. Set the R port. So over here, I'm going to attack on the port number 21. So on the Windows server, I'm going to activate the port. So the port 21 is activated. So before that, let's do a simple nmap on the server IP address to check whether the port is open or not. So over here, we're going to perform nmap-a-d4 on the IP address of the victim to check what are the number of ports are open. And on the victim server, I simply run an FTP server. So we're going to attack on this specific port. So let's wait. The 99% has been completed. Okay, so it's taking some time. 1 second left. Okay. Yes, so the scan has been done, and over here we can see that there's a port number 22 is open, and we can cross verify this one with the help of netcat also. So we can see we can communicate with the server with the help of netcat. So what we're gonna do over here, we're gonna perform a brute force attack on the port 22 on the server 108. So set R host. We're gonna use set S host. So for S host, we have to give a router gateway IP address, and yeah, nothing else required. We can see the timeout. So let's show options. And for monitoring, I'm going to use Wireshark over here. Yeah, So we're going to use Wireshark. So let's exploit it. So it's on flooding mode on the port number 21. So we can see on the Wireshark right now. So the packet has been generated between the IP address. So it's basically on the flood mode on port number 21. We can see the connection has been refused now. On the server side, you can try to check on the task manager. Because you can see through the attack that on the 108, the port number 21 was basically attacked by the synchronization packet. And over here, through the netcat, we can identify the connection has been refused because of the busy port. And you can see over here on the Wireshark now we can see the request. So over here, it basically focusing on the attacking on the port number 21 on the 108. The port number 21 was an attack, and you can see the proper connection with the sync plus RST plus sync. We are not going to accept any of the acknowledgement packet because in the backend of the server, the port has been consumed. If the victim is using any kind of monitoring tool, he can simply check the packets over here in the proper way. With the help of Wireshark, we can simply check the analyzing how the packet is responding. And over here, the connection is still refusing because his port is over there. So this was a proper attack of your synchronization attack. How the sync attack works. Yes, Rahul sir. So this was a proper type of attack on So this was an attack called sync attack flood, where we can simply attack or be busy alignment services on the system. Either you can try many kinds of attack on the server side. Let's stop this one, and let's try to communicate with this one again. The connection has been refused again because the connection is busy until they restart the connection. See, you have to make a proper request. That's why over here, if you see, there are lots of types of attacks again. Icmp flood attack, which is your ping of death attack. Internet control message protocol is a type of attack in which attacker attacks using Icmp request. Icmp is a supporting protocol used by network devices to operation information, error and indications. These requests are either response consume resources of the network devices by flooding the Icmp request without waiting for the response, overwhelm the resource of the device. So it's a ping of death attack. Over here, you will see lots of types of attacks. Peer-to-peer attack, which is also your DDoS attack. Permanent denial of service attack. Application level flood attack. A peer-to-peer DDoS attack exploit bugs in peer-to-peer server or technology using by direct protocol to execute DDoS attack. Most peer networks in DDC client. Each client based on network is listed on the network hub. So it means it's all about attacking on the services or the devices. Once it's compromised, it becomes easy for the attacker to peer to a network. It's deployed among the large number of hosts. One or more malicious hosts is peer-to-peer network can be performed by DDoS attack. So there are lots of types of attacks you can try. For example, permanent denial of service attack, which is called PDoS attack. This is the DOS attack, which instead of focusing on the denial service, focus on the hardware substage. Affected the hardware by PDoS attack is damage requiring replacement of reinstalling of a hardware. PDoS is performed by the method known as flashing that causes irreversible damage of the hardware, breaking a system by sending fraudulent hardware updates. See, over there they have given application level flood attack. This is also attacking on the application level, targeting on the application server with the client computing running in the applications. An attacker find the fault and flow in the application or operating system and exploit the vulnerabilities to bypass the access control, gaining control. So it's like system hacking, some kind of. Distributed reflection denial service attack. This is a type of DDoS attack in which intermediary and secondary victims are already involved. Intermediary and secondary victim. It means the compromised PC, the zombies, you can say. So attackers send requests to intermediary victim, which redirect the traffic towards the secondary victim. Secondary victim will redirect the traffic towards the target. Okay, so it means it's a chain, a loop. I will send the first request to the second one will send to the third one, and the third one will send the victim. So it's like a spoofable attack. So over here they have given a proper commands of DOS, how they're going to perform: command control, zombies, attacker, victims. So the attacker will send to the command control will send to the zombies, and the zombies will send to the attack target, and the attacker will also send to the victim also, which will convert into zombies. Attacker compromises victims to make a bot which compromise in the system to create botnets. Botnets are used for continuously performing a task, which malicious botnets gain to access to the system. You can see how to set up a botnet. Botnet is just like you have to compromise a vulnerable server on the network, which is affected by a common type of malware. A botnet is typically a set of installation of botnet which using a Trojan horse. A Trojan horse carries a bot as a payload which forward to the victim by using phishing or redirecting to their malicious website or a compromised legitimate website. So you will see scanning vulnerable machines. It's giving proper techniques. There are several techniques used for scanning vulnerable machines, including random, histless, topological, subnet, and fragmentation scanning. So they have given a proper scenario of scanning technique. Random scanning techniques, infected machines, randomly from IP address. Hist scan techniques, topological scan techniques, subnetting scanning. So this process is to identify on the local server, to identify the zombies over there. That's why when we are doing when we are performing a PT or a pen testing on an organization, we have to check all these things one by one: attacker, victim, next victim, or the central source. So over here they have given the proper things. If you go down, you will see some tools, DOS and Ddos tools. Pandora's Ddos tools is developed by Russian individual Sokel, who was developed Dirt Jammer toolkit. 5 types of attacking includes infrastructure. We can try HTTP mining, HTTP download, HTTP combo, socket connect, max flood. Other DDoS tools like Darius, HOIC, DOS, SMTP, Bangladesh, DOS attack like Android, low orbit iron cannon, which is your LOIC for mobile applications. And over here, we have given a proper sequence how we're going to use sync flood with the attacking machine. So we have already performed this attack. You can see MS console. They're going to use the auxiliary DDoS sync flood. They're gonna set all the things over here one by one. You can see set as host timeout. You can extend the timeout you want on the port number. But over here, now log into the Windows 7 machine, task manager, and observe the performance graph. Yes, this is an important part. You can also use the Wireshark as we used it. So we're gonna try the tool called Sync Flood Attack with the Icmp 3. So let me tell you about the Icmp 3. Icmp 3 is the most common tool which is used for pen testing of firewall, which we can simply use it for creating, you can say, our own customized things. So over here we can use Icmp 3 for flood. They are using -, flood. So let's try to use Icmp 3. So over here again to the Kali machine. So let's write man Icmp 3. So Icmp 3 send almost arbitrary TCP/IP packets to the network host. So Icmp 3 is a network tool able to send custom TCP/IP packets and display target replies like ping, probs, doesn't Icmp replies. So over here you can see test firewall rules, advanced port scanning, test net performance using different protocols, packet size, or you can say path MQ discovery. You can try lots of things over here. But over here we're gonna try Icmp 3 -help. So we're gonna start with the random flood mode attack. We're gonna use -flood. Send packet as fast as possible. Don't show replies. So I'm gonna try with the common one, and I'm gonna use Wireshark over here again. Yes, and the victim machine is all still running. So let's try. Yeah. So we're gonna write Icmp 3, the IP address, and -flood. So let's try with this one first. So Icmp 3 has one flood mode, no request. So we can see it's on attacking mode, and we have to stop this one because it will overload. And you can see the number of packets in a second, 6 to 2580. And over here, we're going to try to communicate with any of the services on that. So over here, I'm going to use the netcat again. Let's try with the port 21. Yeah, it's running because we are not attacking on the specific port. We are attacking on the server. So it will take some time when you're overloading the resources. There are many techniques that you can use. For example, you can specify the port number. You can specify the port number with the capital S, with the -P, with the port 21. So -S over here means the sync packet, and the -P is the port number. So it's basically running, it's gonna send some synchronization packet on the port number 21. You can see over here with the capital S. So over here we can see synchronization packet, and -P stand for destination port. So let's try again, and we can see the port has been refused because the number of packet has been sending over there, and we can see that FTP server has been occurred a problem over there. So there are many techniques that we can use for attack on the server side. With the help of the HPing3, we can try to perform lots of things over here. But the most important part when you're performing a HPing3 attack, remember the cheat sheet. So either you can use the HPing3 cheat sheet, or you can write HPing3 Ddos attack commands. See. So they have given lots of commands over here that you can use. For example, they have given HPing3 trace route to check the packets, and -b for the verbose, and -l for the length, and Icmp mode, and we can see the example. So let's try with this command to trace the packets. So over here, I'm gonna use the on the server 108. So we can monitor all the number of packets. So it's gonna send some Icmp packet on the server side. See. And over here, let's try. It's a Icmp attack. This is making a proper sequence. But over here, the main objective, we can simply analyze the packet, how many number of packets have been sent, and the sequence number plus the number of time. But the most important part is to customize the packet that you're using. DDoS attack, a distributed neural service attack, is similar to a DOS attack, but carried out on different nodes. So over here, we can see about HPing3. The tool HPing3 allows you to send manipulated packets. The tool allows you to control the size, quantity, and fragmentation of the packet in order to overload the target by bypassing the attack firewall. And this is a security capability testing course. You can see all the things one by one. How to install this one, and over here a simple DDoS, not DOS attack. So you can see sudo -s for sync flood, -b the verbose, -p on the port number, and the sequence. So over here you can try these things. Let's run the FTP server again. So over here it's running. So port number 21, yeah, and the IP address. So let's cross verify. Condition diffuse, yes. Stop this one, otherwise the packet will be overloaded. Yeah, I guess I have to stop it over from here. So you will see the lots of packets which is generated with the help of HPing3, and they are properly crafted packet. See, a sync packet from the 1010. So HPing3 is basically used to test the network or the firewall network system plus the router on the network. So you can look for the data on the server. There's a lots of things you can try, and they have given a proper descriptions. -s for specify the sync packet, -f flood, short as descriptions, -v verbosity, port 80, you can replace the port services as you want to attack, and the target IP address. You can try the random source. Random source will change the random source IP address. Hide IP address. -d, you can specify the data type. Set size of the set packet size. -n, show the IP instead of the host. -q, brief output. You can see there's a lots of things I'm given. All you guys need is to learn all the things again, and you need an attacker and a victim over there to complete the target. And these nodes cover all the things one by one. But the most important thing, remember, is the countermeasure. In the last and the least, you have to protect the server. Detection techniques, activity profiling, wavelet analyze, sequential change point detections, DDoS, countermeasure strategies. You have to check all these things one by one. Because when an attack has been occurred, you have to make a proper measurement. And last and the least, your mind map, how you're going to set up all the things to perform. So this was a proper time and the techniques that we used.